this is 4-2 alpha, so we're going here. This is another definition that you're accountable for. The difference between an observation and experiment. So far, we have from chapter 3, which was unit 2, we have the definition of R squared, which is the proportion of change in the output that can be attributed to change in the input. You were accountable for that. In this chapter, we had bias. And bias is when the sample statistic does not map onto the population parameter. The difference between an observation and experiment. In an observation, the participant chooses the treatment. In an experiment, it's imposed upon the participant. And you'll see what that is about when we go to the problems you're going to do. All right? A confounding variable will affect the input and the output. Well, you know, confounding is bad news. So here's an example. You study the lack of exercise and early death and say that they're correlated. If someone doesn't exercise and they die young, there seems to be a correlation. But they both may be influenced by other factors. So, you know, that there could be health factors that prevent someone from exercising. And those health factors may contribute to their early death. There's other things that that would influence both the exercise and the early death. Okay? In the language of experiments, levels are subsets of factors. Well, and again, we'll try and clear that up when we go over a couple of the questions. And when you design an experiment, well-designed experiment would have a treatment group and a control group. And you have a control group to minimize the confounding. Okay, so that the control group would get a placebo. So placebo would be like when you were little and you were kind of a handful, and one day your mother said she had a headache, and you watched her take an aspirin. So the next day, you decided you had a headache. And you wanted an aspirin for your mother. Yeah, and she gave you a sweet tart or some piece of candy and told you it was an aspirin, and then your headache went away. Because it was a placebo. Okay? So you're going to deal with two questions, 47 and 51, and then just read 55. We'll do 55 together, but you're going to do 47 and 51, and 51 is the problem you're going to submit on the Google Doc. Today, the exit ticket is through Google Classroom, and tomorrow the exit ticket is through AP Classroom. So I'm going to pause the video and give you a chance to go over 47 and 51 and to read 55. All right, so we're going to go back and go over this for 47. The input, the explanatory variable, is the time children spend in childcare. That they have to spend, this group is from how much time they spent in childcare until they were 4.5. The response is a rating based on their assertiveness, disobedience, aggressiveness. But it's an observation because they didn't go to these families and say, we're taking your child and putting them in childcare. The family made the decision. And then they tracked these children. So an observation cannot be used to identify causation. But it still might give you some useful information. And a lot of times, an observation can be followed up by an experiment if you find something in the observation. Now, in this case, you couldn't follow this with an experiment because you'd still have to go to families and tell them that you're taking their toddler away. But the findings of this might influence parents regarding their decision regarding the child care. Okay? 51. So the factors in this case are the information from the caller, whether they identify their name, their school, both, and the survey results, whether they offered to share them or did not. So there's two factors: the information about the caller and the information about the survey. So these combinations are the treatments. There's two factors, 3 levels for this factor, 2 levels for that factor. So the treatments would be name and offered, name and not offered, survey results. School only and offered the survey. School only, didn't offer it. Name and school, offered, name and school, did not offer. So these are the 6 combinations, right? 3 times 2. The product of the levels, okay? And 55, which you just were to have read, so you have this treatment for arthritis. And the treatment is avocados and soybeans. Well, you need a control group because this is over 3 years. And if people have arthritis, their symptoms are getting worse. So if you didn't have a control group, your treatment group might, their symptoms might get worse. But the treatment could still be effective because maybe it didn't get as bad as the control group's decline in their flexibility with their joints. Does that make sense? Like the treatment could still be effective and people could not feel as well as they did 3 years ago. But the control group, the people might feel, you might be able to measure them as feeling even more of a decline. And when you participate in these experiments, you have to realize that you are not aware of whether you're getting the treatment or you're in which group you're in. So, you're doing this to help other people too, all right? So that's that for that's that for 4.2L.